somewhere on a coral reef right now. An animal the size of your hand just threw a punch. You didn't hear it. You didn't see it. It happened in less than a millisecond. But the water around that punch just reached a temperature of 4,000 degrees. That is not a metaphor. That is not a comparison. That is what happened, physically, in the real world. Meet the mantis shrimp. The most misnamed, most underestimated, most biologically impossible animal on this planet. Here is what biology gave the mantis shrimp, instead of size, instead of teeth, instead of venom. A saddle, a spring-loaded saddle structure, compressed inside its appendage. The Dactyl club that stores elastic energy like a crossbow, drawn back and locked. When it releases, that club accelerates at 10,000 times the force of gravity. Let that sit for a second. A bullet from a standard rifle accelerates at roughly 33,000 times the force of gravity. The mantis shrimp is in that conversation. With a body that weighs less than 200 grams, the punch travels at 23 meters per second. That is 83 kilometers per hour. That is faster than the legal speed limit on most highways in the world. And it hits with 1,500 newtons of force. A human punch, a professional boxer at full power, hits somewhere between 400 and 500 newtons. The mantis shrimp triples that, with a claw the size of your thumbnail. But here is where it gets strange. When that punch hits water at that speed, something called a cavitation bubble forms a vacuum bubble. And when it collapses, it releases a flash of light, a shockwave, and enough heat to approach the temperature of the surface of the sun. 4,000 degrees, some measurements show even higher. The mantis shrimp does not just punch its prey. It punches the physics of water until water itself becomes a weapon. This is why mantis shrimp in captivity have been known to punch through aquarium glass, not attempt to punch through a quarter-inch thick glass wall. Gone. Because the animal decided it was time to leave. There are two types of mantis: shrimp, spearers, and smashers. Spearers use sharp appendages for soft prey. Smashers, like the peacock mantis shrimp, use that dactyl club for hard-shelled animals, crabs, clams, snails, and the club itself is one of the most advanced impact-resistant structures ever studied by materials scientists. It is made of hydroxyapatite crystals arranged in a herringbone pattern that redirects cracks instead of propagating them. Boeing and the US military have studied this structure, not to understand shrimp, to build better airplane fuselages and body armor. An animal that lives in a coral reef burrow has already solved engineering problems that humans are still working on. Now, the eyes, if the punch makes you uncomfortable about your place in the animal kingdom, the eyes will end you. Humans see color because we have 3 types of cone photoreceptors in our eyes. Red, green, blue, everything you have ever seen, every sunset, every painting, every face you have ever loved, was processed through 3 channels. The mantis shrimp has 16. 16 independent photoreceptor classes, not 3. 16 they process ultraviolet light, infrared light. They perceive polarized light, linearly and circularly, which no other animal on Earth does. They can detect the difference in light wavelengths, as small as 1 nanometer. What does that mean for what they see? Honestly, nobody knows, because to understand what it feels like to see with 16 photoreceptor channels, you would need a brain built to process that. Human brains are not. We can measure the input. We cannot model the experience. There are colors the mantis shrimp sees that have no name in any human language. They do not exist in any human experience. You have never seen them. You never will. The mantis shrimp lives inside a sensory universe that is completely closed to us. And here is the paradox that marine biologists have been arguing about for over 2 decades. Despite having 16 photoreceptor types, mantis shrimp appear to be relatively poor at distinguishing fine differences in color compared to humans, which means the 16 channels are not being used to see more detail. They are being used for something else entirely. The current best hypothesis is that the mantis shrimp processes color like a satellite, processes spectral data, parallel, simultaneous, categorical. Instead of comparing colors against each other to distinguish them, the brain reads each channel like a yes-no signal. It is not seeing your world in higher resolution. It is running a completely different operating system. Those same eyes move independently of each other. Each eye scans its own visual field, reads its own data, and sends separate information to the brain at the same time. The mantis shrimp can look at two completely different things simultaneously and track them with depth perception and trinocular vision, all within a single eye. We have two eyes and struggle to multitask. The mantis shrimp is running 16 sensory channels through two eyes that move like autonomous machines. So why does a small crustacean on a coral reef somewhere in the Indo-Pacific have all of this? Because evolution does not care about what is necessary. It cares about what works. The mantis shrimp punch is not overkill. Every animal it hunts is armored. Hard shells, calcified structures, defensive bone. The punch is exactly what is needed, calibrated over millions of years to crack exactly the kind of prey it hunts. The vision is not excess. It is a specific solution to a specific problem. Coral reefs are some of the most visually complex environments on Earth. Detecting polarized light helps identify prey that is transparent. UV vision helps read the bioluminescent signals that mantis shrimp use to communicate with each other. And they communicate. Mantis shrimp have complex social rituals. They recognize individual partners. They demonstrate mate fidelity that lasts years. They use fluorescent patterns on their bodies to signal threat status and reproductive availability. There is a conversation happening that we cannot see, in wavelengths we cannot perceive, about information we cannot decode. The mantis shrimp is not a primitive animal. It is an ancient one. Stomatopods have been on this planet for 400 million years. They predate the dinosaurs. They survived 5 mass extinction events. Whatever they are doing it correctly. Materials. Scientists study the club. Neuroscientists study the eyes. Mechanical engineers study the saddle spring mechanism. And they keep finding solutions to problems that human technology has not fully solved. The mantis shrimp is small. It lives in a hole. Most people have never seen one outside of a documentary. And it is quietly teaching us how to build armor, how to process light, how to transfer force without destroying the tool that delivers it. The universe did not just put extraordinary things out in the stars. It buried them in coral reefs. It gave them claws. This was the mantis shrimp. One creature, one universe. If you think you have seen what life is capable of, you have not started yet. New episode every week. Subscribe to CreatureCosmos.